You initiated a connection between extremal graph theory and Ramsey theory, so the so-called Ramsey-Turan type questions. Can you say something about this area?
We had a problem with Erdős. We formulated for hypergraphs, a very innocently looking problem. And it turned out that it became important also in this additive number theory, in the Semeredi type results. So, for example, now in Minnesota, where there was a conference on Semeredi, about Semeredi and Abel price, then out of the 10 lectures, maybe including mine, it was mentioned 3 times, because it was solved, the problem was solved by Ruzsa and Semeredi, and then it turned out, and it is again a very surprising part of the history of mathematics, that this extremal hypergraph problem turned out to be strongly related to additive number theory, more exactly to arithmetic progression and things like that.
Now, this is the so-called 3-6 problem. Could you state what that problem was?
Yeah, it is very simple. It is a special case of a general problem. If you have a triple system, which means that you have points in the space and points, and you take a few from the triples. And you know that if you take any 6 points, you will have at most 2 triangles, which is spanned by this, which belongs to these 6 points. And which means that less than or equals 3, less than 3. And so it became the so-called 6-3 problem. And therefore
But the question is, what is the maximum number of triples you can have? So it's the density of the triples.
Yes. What is the maximum number of triples? And Ruzsa Semeredi proved it. And it turned out already in their paper that it is very strongly related to arithmetic progression questions. And if you mention that I should mention it explicitly, that I must say that the next value, so taking instead of 6, 7,
so instead of 3, 6, taking 4, 7, yeah.
And taking 7, 4, the similar problem, then it is still unsolved.